Okay, good afternoon. I hope you are doing well. I think we are missing other students. Anyway, we will start. Yeah, we have another visitor. Here in this example, this is all about the design of the storage, and you may need them in. This is the way that we are using the calculations for how to design any storage system, especially for domestic one. There is an example here, and in this example, and usually we have like this example in the real life. Here we'll have two things. We have um, yeah. So we have this example. Here we have a cafe which is called Onur, and we have another cafe or grammar here. So the ways are going from here, this shop and this shop, and this should be like this, and the flow will be here, and there will be another flow, and here is the direction of the flow when there will be like this. And here we have the main sewage. This pipeline is the main sewage. It means that we may have a street here. So you can see here is the direction of the flow will be like this. And what we have to do starting, so the design procedure is, first of all, we have to put a manhole here and a manhole here. And there will be another manhole here, and manhole here, and manhole here, and manhole here. We say that at least with the spaces between each manhole should be what? Do you have any idea? The distance between every manhole, each manhole should not exceed 100 meters. This is usual, okay? So you can see here's the distance between manholes. It will be this 76.2, 61, 91, 91, 91. And they are all less than 100 meters, which is very important. Now, you can see there's points here. These numbers are representing the ground elevation. So the ground elevation will be here is 201, 201, and 119. So it looks like we have a hill here, and the flow will be going down. So the flow will be by gravity. It will have here top, we have here bottom. Now, what that means that we have a sewer here lower than this sewer, lower than this sewer. Now, look at the number of the manhole. How do we number in the manholes? So we have manhole number 15, manhole number 49, manhole number 48. And there will be manhole number 47 after this. So you can see it because there is a branch here. As an engineer, as a site engineer, I'm advising you to follow this kind of naming the manholes. So this is manhole number 48, 1, manhole number 48, 2. It means that it will relate it to 48, and it will be the number 1 after manhole number 1, 48, and it will be number 2, and it will be number 3, and it will be number 4 here, 4 here, and there will be number 5. So this is as a first step for your design, how to start. You have first to find these numbers. This is from the surveying. And the other one is to find the Q. By the way, we have to have the Q that will have to flow from this manhole to that manhole. And so we have the flow through this example, by the way. we have this example. It said that we have a flow which is I think here, yeah, the flow that we have from the this coffee, it will be about, yeah, from the peak flow, yeah, right, the peak flow rate from the coffee and this one, the dairy creamer, is 20.2 liter per second. So we have 20.2 liter per second cubic. This will be 20.2 liter per second. Okay. Another important thing, I think, yeah. So this is 20.1. This is the flow. And we have the other one, which is the 48.5. We have this one. Now, how shall we start? We will start with, first of all, we have to put the manholes here. And we start to have, so this is very important table. This table is a very, very important table. And you need to have this design table for your, for your, at least for your, also for your design project. Now, for this project, the design will be following in this table. The table, you have to start with the line. So line one, I mean by the line one, here's the line one. This is line number one. There's line number two. And there is line number three. There's line number four. And finally, we have line number five. So how many lines, I mean by the lines means sewers, how many sewers that I have to design? 5 sewers. Now the number of manholes R's is equal to how much? 1, 2, 3, 4, 5, 6. So we have 6 manholes. Now for each line, we have to have, this is line 1, so you have to mention this from manhole to manhole. So from line 1 is the sewer line between manhole number, which number is this manhole is? Madam? Nobody? Yeah, so it will be from manhole number 1 till manhole number 2, and manhole number 1 here is, it's 485. This is means by this one. And the end, or the 2 manhole, is manhole number 485. So the line is, here is the line. This is the line number 1. This is starting manhole 48.5, 48.4. This is a number of manhole. Now, what is the length of this pipe? The length of this sewer is about 76.2 meters. So you have to mention, and this is 72.6 meters. Now, what is the flow? The flow is given to you. It's 20.2 liter per second. And this should be mentioned here, the flow, and you have to convert it to meter cube per second. So 20.2 divided by 1000, it becomes 0.0202. And what will be the diameter? The diameter of this line, we have to start with the first allowable diameter, or the smallest allowable diameter for this sewer is 250. 250 is the first one, which is 250 millimeters. This will be the smallest smallest sewer that we have to use it. If you are using, by the way, concrete and verified clay, vitrified clay sewer or clay pipe. This is vitrified clay, and this is concrete. Maybe we may have for plastic or corrugated plastic pipe, we may use less than 250. Also, you can use 200 millimeter sewer pipes. Can be given to you, and you can have it from the standard of what we have it in the design criteria that you are following. For example, if you are following the design criteria of municipality of Suleymania, they are asking you not to start with, at least you have to start with the smallest 200 millimeters to 300 millimeters concrete and 250 plastic pipe. And yeah, we may have this one. Yeah, we may have these pipes for 8-inch pipes. We can have this one and 250. So 250, it's 10-inch. We can use for plastic pipes, we can start with 200. This is the based on the regulation that we have from the municipality. Anyway, back to our example. Now, after that, we have this one. We have to go with to this column 7 and column 8 from this table. So we will nominate the first one. Sorry. We will nominate the. Okay, we will come with this one. You can see there is a ground elevation. Ground elevation for what? For the manhole. So we have to go with the manhole number 448.5 and see what will be the ground elevation of this manhole. And what will be the next? It will be from upper and lower. I mean by the upper, I mean by the of this pipeline. So the upper of this pipeline, here's the upper of this pipeline, and the lower of this pipeline. What we have here for the upper is 201, and the lower we have 201.8. So there is 201, and 0.1, 201.8. It means that we have this area is lower than this one, as in the nature. The ground level, we have 70 centimeters different. So the level will be like this. We have a drawing for this one. Yeah, like this. This is the first manhole. Will be the first manhole. Yeah. So 201.8. This is the second manhole, and this is the 201.1. So 201.1 is the ground level. Here's 201. 201.8. This is 201.1. So it looks like I'm just going a little bit with a higher elevation, but it doesn't matter because we are not, the sewer will be, because the flow will be in this way. So you have to have a low, the slope, the minimum slope of the sewer should be like this. Now back to the columns, the column of the design that we have. We have, where is it? Now I have the ground level, upper and lower level will be here. So we have 201. So there is a grade. The grade, it means the slope of the natural ground level, the surface. The surface, it means the way that we are going to. So there is, this is the manhole number 48.5. This is the surface, the manhole 488.4. So what will be the elevation here is 201.1. The elevation here is 201.8. So the slope of this grade and the surface slope is equal to 201.8 minus 201.1 divided by the length of this pipe. So you can see the length is 76.1 meter. So what will be the slope? The slope will be equal to 101. Sorry, it will be 201.1 minus 201.8 divided by 76.1. So we have about minus 9.1 times 10 to the power minus 3. And this negative, it means that we are going from low elevation to higher elevation. It means that we are rising. Okay, this is the 9.2. Now, this is what belongs to the surface line, the ground. Down of this ground, let me say this is our case here will be like this. So you can see here is the natural ground level. We said that is manhole number 48, and there will be a sewer line. The sewer will come with this white line. So this is line 1. This is 485 manhole. This is manhole 484. Now we said this is 201.1, 201.8. So the slope of this is the surface grade, which is equal to this divided by the distance. The distance between these manholes is 76.1 meter. Now I want to see the slope of this sewer, which should be at least we have for this sewer we have a minimum slope. We say the minimum slope is that slope will help to not have at least a flow of lower than 0.6 velocity in this sewer. So what should we do? The minimum slope for the pipe, and by the way, this pipe, the used pipe, it's called clay pipe, which is close to a concrete pipe. Here's the VCL. Existing sewer main pipe. This is the main pipe. That's design of sewers. Usually you are using, because this is a company, you are using a concrete, and the concrete pipe or clay, they have a manning coefficient is equal to 0.013. Here's the table that if you are not, this is the one that we have, the table of the manning coefficient. The manning coefficient here is the manning coefficients. Usually for concrete, reinforced concrete pipe and vitrified clay pipe, these are two pipes main commonly used, and the commonly value of n here is the good quality one is n equal to 0.013. Okay, now what should we do with this one? We have to go to find the minimum slope. We have the recommended minimum slope for the climate is 44. We are starting with 215, so the minimum slope is 0.0025 or 2.5 times 10 to the power minus 3. This is to guarantee velocity equal to 0.6 meter per second. And if you are not having this table, you can find this one. How to do that? We have the Manning coefficient velocity is equal to 1 over n r 2/3 s 1 over 2. So to find this is to find minimum slope if you are not having this one. So I will assume that the minimum velocity will be 0.6 meter per second, and I will use Manning, which is 0.013, and the value, here's the value of r. The value of r usually is equal to d over 4. I'm talking about fully flow. So the d over 4 is the d over 4. So we can use the diameter. Here is the diameter that I'm using. It's equal to 250, which is 0.25, divided by 4 power 2/3 s power half. So find the s. The s will be equal to 0.25 divided by 4 power 2/3 and divided by 0.013 divided by 0.6 and inverse that and square that. So it's equal to 2.45 times 10 to the power, and it means 2.5. Now what we have it here. This is in case that you don't have this table. Yeah. So we have to go with that law. So what we will assume that this is in case of full flow. This is not a real one. By the way, this will help you. When I say the assumed 0.0, yeah, we have to use the 0.025. But check look at this one, the velocity when we have this one. It will not give you exactly the 0.025, so I'll increase minimum slope by 2.029, because this is in case that we said that we have fully flow. For fully flow, when we have 215 millimeters pipe diameter, the slope will be about, and when we have a pre-full, will equal to 0.6 meter per second, so the slope will be 0.0025. Now what I will do, I will increase that slope, because later on this is not to be fully flow, it should be partially flowed, so this velocity going to be lower one. We will check that one. So I'm using more than this one, so I will use 0.026. Or you can check this one. If I have 0.025, sorry, this will be 0.29. If I have 0.025, 0.0245, I will get another velocity. Now, after having that velocity, I should check the velocity flowing fully. And this is also will be should be found. How to find this one? I have the S, here's the S, and I have the diameter, here's the diameter, So, and I have the n, which, so we have 1 over 0.013 times d, which is equal to 0.25 divided by 4 power 2/3 s, which is 0.0029 power 1/2. So I can have a full, this is called the fully velocity 0.065 meter per second, which is greater than zero point 0.6, so we are good. Now, when we have fully flow and we have a diameter, so the Q full is equal to V times A. Where is the V? The V is this one, which is 0.65 times what it will be the area. The area, it will be the area of this sewer, which is 0.25 square pi d square over 4. Okay, let's check that one. So pi d square, which is 0.25 square over 4 times 0.65. Now would be 0.0318. 03. This is will be 0.318, or it will be point. So this is the Q full. Now look at this Q. This is the fully capacity of this pipe, and also we have in this table the fully capacity. Yeah, this one. But this is in terms of this flow. When we have 0.029, it will be more. So yeah. This is the flow that this sewer can hold. Now we have not that much sewer flow. We have a little bit less than this one. What will be the flow? Here's will be the flow. The real flow is 0.0202, and the capacity of the sewer is 0.0321. So small q here is equal to 0.0202 meter cube per second. And the capacity of this sewer is 0.0321 meter cube per second. Now, I want to see how much it will be the ratio of the small q over capital Q. Why I want to define this, which is equal to 0.0202 divided by 0.03212. It will be about 0.63 or 63%. That means you have to go to find the d over t. From which curve? From the partial curve. And here's the d over d. For d over t, oh, I have it here. Yeah, this is d over t. Now I am using this value, which is 63%. So this is 63%. This is 6, 7, so this is 63. I will go with the, and also yeah. So this is will be the value of it's about 0.75 really. It's 0.75. Oh, so d over d it will be near to be 7.5, and we need this one to be mentioned in our calculations. Now, okay, so we have d over d. And then from d over d, q over q 0.63, we will have d over d about 0.75. And also I can see what will be the value of the v over v, because the first v that we found here is that when we have 0.63, yeah. So look at this one. Oh, I did a mistake. I did a mistake. Here's the mistake. The mistake is that we have the q over q. Here's the q over q is 0.63. So 0.67. This will be 0.63. And here's the 0.63. And look at the, yeah. So the d over d, it will be about 0.55. And the same way, what will be the value of v over v? We can find this one. Okay, yeah, it will be between 0.9 to this one. It will be point. Yes, we have to go with this one. 0.63, and it will, yeah, it will be about here 0.92. So this is the flow that we will have. Now, what should I do with this one? 0.922. The V over V. What is that V? This is the real, and this is for the view full. The view full that I have here is this view full. I say that it will be equal to 0.92. The 92 is the 9, yeah, is the ratio of the V to the V, 0.92. Now I have V full, or the full capacity. When we have a switch working in full capacity, how much it will be this flow? It will be 0.65, as we here have column 11. Now I have this one, so I will check with the real, which is equal to 0.92 times 0.65 meter per second. And then I can say the velocity will be, real velocity in this one will equal to 0.6, which, okay, this one should be greater than 0.6 meter per second. Now, after this one, I have to consider, then the slope will be, the slope for the line one is the one that we selected, which is equal to 0.029. 0.029 will be the SOAR of the first line. So the slope is equal to 0.029. This is the slope. Now we have to mention this. How much is the drop down? How much will be the drop down from this? This is called invert level. Invert level of the manhole 485 and the invert level manhole number 484. So how much it will be the distance? The distance or the drop down, it will be the distance times this much. So 76.1 meters should be multiplied by 0.0029. This is the slope of this now to get how much is the drop. How much should we have to the difference between this invert level and that invert level, and it will be equal to 76.1 times 0.0029. It will be about equal to 0.22 meter or 22 centimeters. So the invert level, the bed level on this sewer, and the second one, we have the second one lower than the first one by 22 centimeters. Now, then what should we do? We should know how much is the whole excavation or the depth. The depth, usually we are using for the first sewer a depth of what? A depth of 3.5 meter. This is, you have to use it for the first manhole, 3 meters to 3.5 meter. Now, what will be the depth of the second manhole? It will be the depth of the first manhole plus the drop. So 3.35 plus 22 centimeters or 0.22 meters, it will become a 3.57 meter. This will be the depth of the second manhole. Yeah. And this will be the depth of the 3 meter, 3.57. Now, what will be the bed, the elevation of this manhole? We have here 201, 201.8. So 201.8 minus 3.57 will give you the bed level of this manhole, which is equal to 201.8. 200.1 minus 3.57, which is equal to 198.23. So it's equal to 198.23. And you can check this number. Now for the invert level or invert elevation, so the upper, yeah, here's the fall, sewer fall for this one, the velocity, and the upper elevation, here's the 197.7. And where did this is coming from? This is coming from that the ground level of the first manhole is 201.1. So this is a very important thing you have to take care about. Where did the invert elevations come from? For manhole number 1, upper manhole, we have the 197, means by the level of this upper manhole, means by this elevation. So yeah, this is the upper elevation, and this is the lower elevation. What will be the, this is 201.1 as we say. So after using 3.5 meter, what will be the elevation here? It will be 2.1 minus 3.5 meter. So we can have an elevation of 201.1 minus 3.5. You will have 197.6 meter. This is the elevation of this one. And what will be the elevation of this one? It will be the surface elevation minus the 3.5 meter again, and minus the drop down that we have from the sewer to that sewer, which is 22 centimeter. So yeah, so 109.96. The upper elevation 196.6, and the lower one is yeah, 3.35, not 3.3, 3.5, but 3.35. The lower elevation would be now 197.53. Now, what will be the next design? The next design is that this manhole we have the bed level of this one will come here, and then after that we are going to find the next procedure, and we have to check for the velocity for the other sewers one by one. The one point is that if in case that we have a different the differential between the levels that we have, or the higher sewer velocity, we have to make another kind of manhole, which is called drop manhole. Drop manholes will come when we have the difference between the in and the out by more than 0.60 meter or 60 centimeter. If you have the drop was more than 60 centimeter, then it's called, we have to revise the manholes and go with the other points one by one. This was my lecture for today. I hope you have to redo all the steps and make an Excel sheet for this calculation and see a check for all, and this will be considered as a homework for you. Thank you and see you in tomorrow. Bye bye.